In this video, we're going to be picking this. This is an Abloy profile. This is called a disk detainer lock. What's special with these locks is that they don't have any pins, they don't have any springs. A normal lockpick is useless on this type of lock. We need a dedicated tool that is able to open them, and that tool is correctly called an Abloy profile pick. To make the Abloy profile pick, we have a process tree that we need to follow. So starting off here, we have two parts that are going to be made in parallel. We start off here with the lathe, and we're going to be turning the tensioner, the picker, and the handle at the same time, using CAM2 turning, as well as the NC Sender software. From there, we need to heat treat them, but we don't know how to heat treat this material, so we designed some test coupons, do a flexibility, hardness, and ductility tests of the material before we heat treat billets. From there, we can use our CAD software to design a holder. We can then machine that holder with the 3+2 CAM2 milling software. Then we can mill the tensioner, and from there we can mill the picker and the handles and everything else that follows, polish it, and assemble all of the four components that were just made. Alright, here we are. These are the pieces of material we're going to be using. This is a piece of aluminum, will be used for making up the handle. This is T6 aluminum, I think. And these are the pieces of material that just came in. They are made from silver steel, good quality silver steel. We're going to be using a 8mm bar for today's video, so I can put these away. Here's what we're going to do. Firstly, this is the silver steel. Approximately 10 or so centimeters will be cut to make the tensioner. Then we'll use about this much here to make the picking tip. We can cut the bar probably around right here. This is for making of the handle. The handle is a little bit longer here, so this is the rear handle, this is the front handle, and then this is the fixture. And we'll cut that out approximately right here. This is something I have not used in a little while. This is the heat treating furnace. This will take a few minutes to heat up. We can go over here to the 5-axis milling machine. All right, let's get to work with setting up the milling tools. To begin with, we're going to need a 4mm end mill. I have one here for aluminum. We're also going to need one for regular steel. One here is actually for hardened steel. I kind of sworn I had more of these. Let me see if I can find it. I thought I had 5. I did have 5. Okay. This one here is for regular steel, so that's pretty useful. This one here is for aluminum. Keep that cutter. This is a 1.5mm cutter for aluminum, also very useful. 6mm end mill, I don't know if it will be 3mm, okay. We also need some thread milling tools. I have this one here, I think this is M4. Let's see here. Yeah, it's probably M4. Let me just measure it. It does say it on the engraving as well, so we'll double check that. We need a 4mm drill. Now we do have one here. It's high-speed steel, so I think we'll swap it out with carbide. And then we need a 3.5mm drill. We need a 2mm ball mill. I have one right here. And we need an engraving tool. I have one right here. We need a 5.5mm drill. Okay, is there anything more we need? Okay, if there's not anything more, then I'll work on setting up these tools here. Now comes the zeroing of all of the tools. We have our holders all turned out, and we have the tips all turned out. I decided to actually leave this little bit here and actually turn it after it's been hardened, because it makes it a bit easier for me to hold it in the collet. Maybe I'll regret that, who knows. It's not really that difficult to turn hardened steel. But now the goal here is to put these in a furnace, heat them up, and then quench them in hardening oil. And after that, we'll leave them baking at high temperature to let these dresses relieve. I might do a couple more cycles of it. And actually, just for good measure, I made one tube here, and it was, well, not very concentric. So we'll harden that tube. And what we'll do here is that we'll carve out the tensioner from this, and then we'll try to break it to see how much flexibility we can get from it. So we have 4 picking tips, 3 tensioners, and then 4 handles. Let's go ahead and get to it. bit unfortunate here. This thing here is like, it will still slide, but it's not, you know, as smooth as it used to be. This shaft is slightly bent, happened during heat treat. This cannot be used anymore. We'll have to make a new one. Here we are back at the milling machine. It's right back. We'll be using this. This is a collet chuck. It holds a collet. Now we can insert this into here. Right. 50mm piece of silver steel, 8mm. Just slip that. Now, before we go to machine this, we probably want it to be somewhat accurate with the axes of the machine. Now, there are many ways to do this. The absolute easiest one is to just use a touch probe if you have one. These are like 7,000 euros, so yeah. I at least have one. Maybe you don't, but I do. But actually, because we're going to be doing a bunch of these, I want to just check that my setup is fine, and then we'll just use the setup. And the thing with the touch probe is that it can tell you if you're correct right here, but it can't tell you if the tool is at an angle. Okay, so it's definitely touching. There we go. You have the tool here in position. It is right in the center. It's important that it's dead in the center. Right now it's within center about 1/100th of a millimeter. Let's go ahead and check the height offsets. This is 28mm. We're supposed to be 26mm or above, and we're more like 30, so that should be fine. You might actually be able to just completely take this off. Yeah, Look at that. It's what happens with smart milling, eh? You don't have to remove so much material. Here we are. Yeah. That is pretty nice. Check the flexibility of this thing. Now we're going to check the flexibility of this a little bit. This is like the sacrificial one that I made. So let's go ahead and bend it actually. Piece of aluminum, here's the picking tip. Let's say that you're some sort of noob and you're abusing it. Yeah. Oh yeah, that's, we're putting in a lot of force on this thing. See here that, like, we're really moving. And it is not breaking. You know what? Let's go ahead and just push until it goes. Okay, so it does not break. And this takes a significant amount of force. I'm really pushing it here. We're actually able to push it back also. Let's go ahead and push it back and forth until it breaks. Oh yeah, that's, oh. Okay, so it's not indestructible, but that took a lot of abuse. Definitely more than you would ever see when picking. So yeah, we can surely say that this tool is pretty strong. Okay, we have 2 extra of these. That's a nice thing to have. And I also have this one here that I made a long time ago. Got to say, you know, ignore the color, but the production quality of these is quite fantastic, I think. Sharp corners, crisp edges. Yeah, I'm pretty happy about that. Okay, now it's actually time for the handles. It's pretty simple. All that needs to be done is drill and tap 2 holes here. Inside of here, we need to do a tiny bit of a pocket and drill and tap the holes, cut off the tang on here, just face off. And yeah, that's basically the tool done. And there we go. That is everything completed. I put my name here and my logo. And also here I wrote in cursive Abloy profile, OPSEC AS. Thought it looked nice. I made 3 of them. So here are the other 2. And one of these, which is this one, has the customer's name engraved on it, so I won't show that. But I can show these 2. Yeah, they look really fantastic. They're very smooth to use and should hopefully pick a lot of Abloy profile locks. Hopefully. Hopefully they don't just sit in a shelf. Yeah, I think the machining on these, the machining work is rather nice. Let me get some more light actually. Okay, here we go. Got some more light. I think the machining works on these is really, really nice. It's at least extremely smooth and nice to use and operate. That goes for all of them. Really, really nice, and they fit together just perfectly.